Good evening, ladies and gentlemen, and welcome to my final physics presentation. Today I will be showing you the differences between kinetic braking and braking with the ABS anti-lock brake system. So, shall we begin? For my final presentation, I did braking, comparing locked braking with the kinetic friction between your tires and the surface of the road, versus vehicles equipped with ABS, whose tires will not lock. This is the braking equation. Distance equals velocity squared divided by 2 acceleration mu k. D will be your resulting distance in meters. V is your initial velocity in meters per second. A is acceleration due to gravity, in this case 9.8 meters per second squared. Mu k is the coefficient of friction between your tires and the road surface. Now how does this affect you? This means that if you double your speed, your stopping distance is not doubled, it's squared. This also means that the 2-second rule in driving is completely invalid at high speeds. It also means that you'll usually be able to stop quicker by applying maximum pressure to your brakes without locking them. How has braking changed? Over the past century, there has been many changes in braking technology. One of the most important ones is ABS. ABS was invented for use in aircraft in 1929. Eventually it was put into motorcycles in 1958, and was even tested in racing vehicles in the 1960s. Eventually, the Chrysler Corporation invented its own version of modern-day ABS. They called it sure braking. The typical ABS system uses a central electronic control unit, 4 wheel sensors, and at least 2 hydraulic valves in the brake system. When the computer senses that one of the wheels is spinning slower than the others, or is locked, it will automatically adjust the braking pressure for just long enough for the tires to equalize. Sometimes an alarm is sounded inside the vehicle, but usually it is only detected by the pulsating in the brake pedal. Some systems can release pressure up to 16 times per second. This is a picture of the ABS system, the unit itself, the control module, and all 4 wheel sensors. So how does ABS affect normal braking? ABS has been shown to increase distances up to 27% on slippery roads, but has also decreased braking distances for motorcycles up to 30%. Bottom line, ABS is designed to keep the driver in control of the vehicle during emergency situations, not decrease stopping distances. How does ABS affect kinetic braking? Kinetic braking, or locked wheels, is when your brakes have locked and your tires have stopped spinning. The only thing stopping your vehicle is the friction between your tires and the road surface. ABS allows your tires to go free momentarily, then allows you to apply braking pressure. This should allow you to stop much shorter than when your brakes have become fully locked. This is what I went out to study. That a vehicle equipped with ABS stops shorter than a vehicle who is using the kinetic friction of his locked tires to stop. Here are my following tests. We know the mass of the tire to be 32 kilograms, which translates to 320 newtons of force. To find the mu k of friction, we need to take the force used to pull the tire on the surface, which is dirt, and then divide that by the normal force of the tire. So what we're going to do is use the scale to find the amount of force it takes to pull it. "18 kilograms. We're traveling at 15 miles an hour, which is approximately 6.7 meters per second. It should take us approximately 4 meters to stop. That's commencing in 3, 2, 1. Now let's measure the distance. Approximately 6.5 meters. This is our second test for the 15 mile an hour test. I think I was going a little over, so we're going to do it again. And the cone, single cone down there is the last stopping distance. And so we'll see if we can do better or worse than that. The last test wasn't enough sufficient, so we're going to bump it up to 30 miles an hour, and we'll see how far we stop. The calculations say that we'll stop in approximately 16 meters, which is quite further than our other calculations, so we'll see what happens. Yeah. .7 meters. These are our results for the soft dirt trail. The coefficient of friction between our tire and the surface of the road, μk, was 0.6875. The estimated stopping distance for the first test was 4 meters. The actual distance was 6.5 meters. Both tests concluded that a vehicle without ABS would have been able to stop over or under 3/4 the distance than an ABS vehicle. Our final conclusion is that the kinetic braking seems to be more superior in this terrain than a vehicle equipped with ABS. However, if a vehicle was to use kinetic braking, its tires would lock and it would slide to one side of the trail. Since the trail is so thin, the vehicle would most likely slide off the trail and crash. The next test we will be doing will be on dry pavement. Just like the other ones, we need to find out the μk value of friction by finding the force needed to drag the tire across the surface. "26 kilograms, or 260 newtons. Knowing this, we can find the μk by dividing that by the force of the tire that exerted on the ground. Now we can find the stopping distance by using 11 meters per second, or 25 miles per hour. The stopping distance is approximately 7.8 meters. I've placed a single cone at our estimated stopping distance. Keep in mind, this is the stopping distance for a car whose tires have been locked completely and are now the only braking force. Since my truck has been equipped with ABS, the tires should lock only momentarily, then unlock to allow the brakes to brake to their full potential. .4 1/4 meters. These are our results for the pavement tests. The coefficient of friction between our tire and the surface of the road, μk, was 0.8125. The estimated stopping distance was 7.8 meters, and the actual stopping distance was 4.25 meters. The test concluded that the vehicle equipped with ABS was able to stop in about half the distance of a vehicle with locked brakes. The final conclusion is that on this surface, the ABS vehicle is able to stop much faster than a vehicle that has locked brakes. The next surface we're doing is a packed dirt road. "25 kilograms, or 250 newtons of force. Our μk for this surface is 0.78, which means the stopping distance for 25 miles an hour will be approximately 8.15 meters. .4 meters. These are my results for the packed dirt road test. The coefficient of friction between my tires and the road, or μk, was 0.78. The estimated stopping distance was 8.15 meters. The actual distance was 9.4 meters. The conclusion of the test was that a vehicle with ABS stopped just after the vehicle with locked brakes. The final conclusion is that on this surface, the ABS vehicle and the vehicle with locked brakes would be almost equal and would both remain in control.